Hello, and welcome to Automating Disaster Recovery with Aura API. Today, who will be presenting will be Philip Mortiboy. Over to you.
Oh, thanks, Damien. Hi, everyone. Good morning, good afternoon, good evening, wherever you're dialing in from. My name's Philip Mortiboy. I'm a Senior Engineering Lead at Altrata. And in this session, I'm going to be giving you a quick walkthrough on how we've automated our disaster recovery processes for Neo4j with the Aura API. So at Altrata, we've been using Neo4j to power what we call our relationships engine. And this is a part of the product that's very key to our users that tells customers how they can best connect to the high value people and organizations in our data set. And we display this data very prominently on various parts of the product, particularly these profile pages you see here, where it's kind of displayed right at the top of the screen. And for that reason, we really want to make sure that we have a good user experience and quick disaster recovery if anything does go wrong. And so fairly early on in the development process, we've started thinking about different possible disaster scenarios. And we ended up grouping them in kind of three high-level scenario categories. The first one dealt with data corruption. Basically, what if there's a loss of data in the graph? What if there's bad data written to the graph? Anything that affects the state of the graph itself. And then the second set of scenarios is all around kind of instance instability. So we use the managed Aura service, and we had no issues with it today. It's been a super stable service for us, but at the same time, we always want to plan for the worst in these disaster scenarios. So this category kind of dealt with, what if there is severe performance degradation on the instance? What if there's an instance outage? What do we do in those scenarios? And then the final category was kind of your unexpected events, anything we'd not thought about previously. But as we saw with AWS a couple of weeks ago, these events that are outside of our control can and do happen. So having a plan in place is really important there. So the first set of scenarios is probably the easiest to cover around data corruption. Aura has a really good managed backup service. It takes automated snapshots of the instance every hour for us, does full exportable backups on a daily basis. And this is all managed. There's no configuration on our side, all kind of comes out the box there. And similarly, the restores are equally as easy. You can just go into the console. There's an easy kind of restore option there on the instance to roll back to a certain snapshot. So this is really good. Makes the restore process really simple. But we had a couple of issues there for our use cases. The first one being kind of the lack of traceability when we're doing this through the console, and we need we kind of had a regulatory requirement for our SOC 2 compliance to have audit traces of whenever we're making changes like this to a production system. And then the second piece was we're a big believer in kind of the DevOps principle. If you build it, you own it as an engineer. And so we really want to empower our engineers to have the tooling in place to be able to look after the systems they've developed. But they need to be able to do that safely. And so having stuff like approval gates on running a restore in production is really important there. And so this audit capability, these approval gates, we've already got these built in with our CI/CD provider. And at Altrata, we use GitHub Actions for our CI/CD, but these principles apply whether you're using TeamCity, Octopus, kind of any CI/CD provider. So what we wanted to do was essentially build a GitHub action that would wrap this restore process for us, and then we can make use of all the audit logs, approval gates, and kind of usual systems for running the restore. And so fortunately, this was possible with the Aura API, because the the Aura API allows you to perform pretty much any operation you can perform through the Aura console, but programmatically via the API. So in this instance, we're able to use the snapshot restore endpoint you see on the screen and kind of build an action around that. So the action is very simple. In this case, it's really just a couple of tail commands, one to authorize against the API, and then one to run the actual restore onto production. And then we did end up taking that a little step further, because obviously, you need to know which snapshot you're restoring. So we also built out a corresponding action that would allow an engineer, a member of our product technical support team, to come in and just list out the available snapshots from within GitHub. And so that's the action you can see here. We use there's like a get endpoint on the snapshots where you can just list out the snapshots. And that then gives the engineer a list of available snapshots that they can plug in to the restore action. So nice kind of wrapped up process there. And we get the benefits of all our kind of audit, traceability, and approval gates. So the second scenario is a little bit more challenging to solve. So for this scenario, this is where we have our production instance, but there's something wrong with the production instance, and we want to move over to essentially a DR instance. And so in this scenario, we didn't really want the DR instance to be kind of sitting there 24/7 running, but purely for cost purposes. This is a pretty unlikely scenario to happen. So having to spend a complete production replica sitting there, but wasn't something we particularly wanted to take on. Which fortunately Aurora gives you the capability to have an instance available, but in a paused mode, running at a fraction of the cost that it would be in a running state. So this is great. We're able to have our DR instance kind of there, ready to be used, but in that cheaper pause state. The challenge then, though, becomes if the instance is sitting there in a pause state, it's not receiving data updates. And so in this disaster scenario, we want to switch over to DR, but how do we get the up-to-date data on there? And so this was particularly challenging for us because our core data loads are very, our core data is very highly connected in the graph. We've got probably around 9 million nodes representing these high-value people in our graph. But those 9 million nodes are connected by 700 million relationships. It's a very, very densely connected graph there. And so loading that graph can take a long time, and certainly longer than we want in a disaster scenario. So what we found there was a much quicker way to load the graph is Aura actually gives you the capability to take a snapshot from one instance and restore it onto a different instance. So in this scenario, we're saying that the data is okay, so we can take the data from prod, snap it onto DR, and then fail over DR. The other kind of complication we had there is it's not just one data source being written to our graph. We've actually got multiple kind of auxiliary data ETLs going in there. And of course, the read API that's accessing the data. So it's not just one thing to fail over. We've got multiple systems that in a DR scenario all need failing over to the graph. And the last thing you want in a disaster is having kind of a big run book of stuff to go through, a big checklist of things to fail over. So again, we wanted to wrap this into just a single action somebody could run to orchestrate this whole process. And so that's exactly what we did. We built an action using the Aura API that would first come and turn on the DR instance, get it into a running state, and it did that by issuing a command via the Aura API. We then have a little bit of polling via the API to wait for that instance to return a running state. We then run the snapshot restore onto the instance, again, do a bit of polling via the API to check that restore is completed. And then finally, we ran some stuff on our side to do all the kind of automated failovers there. And so the endpoints we used for this, we used a resume endpoint on the instance for that initial resume. For the status, we just used the get endpoint on the instance. That gives you back a bunch of data about the instance, including the status of it. So we just check for running status. And then for the restore, we actually have to use the overwrite endpoint on the instance because we're coming from a source instance. So this isn't the same snapshot restore as before. And this overwrite endpoint, it gives you a source instance ID and a source snapshot ID to tell it where you want the snapshot to come from. So yeah, this all kind of then got wrapped up into this single action that somebody in this disaster scenario can come in and run. And then for the final scenario, for the unexpected event, what we really wanted to avoid here was kind of a poor user experience where a user's kind of met with a loading screen like the one you see here for any kind of extended period of time. We want the situation where if the relationship engine is down, we know it's down, it's much better just to kind of hide that part of the product. Users can carry on using other parts of the product while we work to get the service back up. And so what we did here to kind of implement this is we put a kill switch into the API that's serving this data. And what happens when we activate the kill switch is we just immediately get back kind of this error response from the API. And it doesn't go and connect to Aura, it doesn't try and do anything, it just errors straight away. And that gives us that quick failure so we can hide the connections part of the product and carry on serving other data. And to build this kill switch, we used launched Arcly at Altrata as our feature flag provider. So this was just kind of a long-lived feature flag. We can go into launched Arcly, turn that on. So nice and easy to activate. The issue though is when do we activate this kill switch? How do we know that we're in a scenario where we do need to go and hide this part of the product? And for that, at Altrata, we use Datadog as kind of our monitoring, our alarming system. And the great thing we were able to do with Aura is Aura has a metrics integration endpoint you can use to essentially ship all of the metrics, all of the logs out of Aura and into a telemetry provider of your choosing. And so with this, we've been able to build out kind of dashboards and alarms in Datadog from our Aura metrics, and from Datadog, chain that onto other providers. So we've been able to build a chain to launch Arcly to then automate some of the controls around this kill switch. And this just goes to show the power of, because Aura lets you export these metrics to other solutions, you can then build really kind of powerful tool chains like this across your providers. So unfortunately, that's all I've got time for in this quick kind of lightning talk. I did notice there's a couple of questions on the chat. So if you do have any questions about this, want to discuss further, please do reach out on LinkedIn. The QR code here takes you to my profile, but to be honest, there's not many Philip Mortiboy, so if you just search for me, you should be able to find me. So yeah, thank you very much for joining this talk.